The James Webb Telescope has made a groundbreaking discovery that suggests the existence of another universe beyond our own recent data from the Webb Telescope focused on the deepest parts of the early universe, suggests that our universe may have merged with another universe. In its early stages, scientists have identified some strange ancient galaxies in the distant early universe that seriously defies our current theories. This new evidence suggests that the early universe we are observing is fundamentally different from the universe we know today. We all kind of, we were literally, as I said, giddy. We designed this telescope to see the very first galaxies that turned on in the universe. And when we saw what it did in only 12 hours, we knew in our hearts that whatever's out there, we're going to see it. New images from the James Webb Telescope may be changing everything, giving scientists a glimpse at what our universe looked like more than 13 billion years ago. And it's not what they expected. Prepare to be amazed. The James Webb Telescope has peered farther into the early universe than ever before, uncovering sights that scientists never anticipated. In addition to these astonishing deep space views, the telescope has also detected some peculiar phenomena. Its recent discoveries have left astronomers around the globe in awe, reshaping our understanding of the cosmos. The universe has always intrigued us with its vastness. We often wonder if it has an edge or boundary, or if it stretches on infinitely according to observations made with powerful telescopes. Our universe began about 13.8 billion years ago. Using this information, scientists developed a standard cosmic model to explain how the universe has evolved. Over time, however, recent observations from the James Webb Space Telescope have challenged these long-standing theories. This telescope, which can look deeper into the early universe than ever before, has captured data that suggests our understanding may need to be revised. Traditionally, we believe that the universe had a definite beginning and has been expanding since. But now some scientists are considering the possibility that the universe might not have had a beginning in the convention sense, or that the early universe was vastly different from what we know today. At the recent 2024 International Space Science Institute Breakthrough Workshop in Bern, Switzerland, a group of scientists summed up some of the Webb telescope's results so far. Their work is in a new paper titled The First Billion Years, according to James Webb Telescope. Scientists have been carefully studying the first billion years after the Big Bang, because according to our standard cosmic model, during this period, galaxies were in their infancy. Stars were forming and black holes were forming and becoming more massive. But to see the first galaxies, we need the most powerful telescopes. The Hubble Space Telescope was limited to observations up to a redshift of 11. The Webb Telescope has pushed that limit right to the edge. Its current high redshift observations reach down to Z equals to 14.32%, then 300 million years. Also, astronomers have detected carbon in a galaxy, observed just 350 million years after the Big Bang, in observations that raise the possibility that the conditions for life were present almost from the dawn of time. The presence of oxygen so early in the life of this galaxy is a surprise and suggests that multiple generations of very massive stars had already lived their lives before we observed the galaxy. All of these observations together tell us that JADES 14 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. With all these data, scientists are now claiming that the James Webb Telescope will soon observe galaxies from when the universe was very young at a redshift of 20. This means looking back in time to when the universe was just a few 100 million years old. However, they are concerned that if the telescope finds even more distant galaxies, this could challenge our understanding of how galaxies form. But according to our standard cosmological model, there is a limit of our universe beyond which we cannot see anything. It is called Dark Age following the Big Bang. The universe entered a period known as the Dark Ages. During this time, the universe was filled with neutral hydrogen gas, and there were no stars or galaxies to emit light, making it opaque and dark so far. Everything we know about the universe beyond the Dark Ages is just theory. No one really knows what lies beyond it. Surprisingly, new images from the James Webb Telescope have revealed galaxies that existed even before what we call the dark ages of the universe. This discovery is baffling scientists, as it's unclear how these galaxies could have formed so early. What's even more puzzling is that these ancient galaxies look nothing like the galaxies we see from the early universe. These findings raise a profound question. Could we be looking at an entirely different universe? Why do we keep finding giant, immature galaxies as we look deeper into the universe? If our physics is correct, we should see small and young galaxies as we look deeper into the early universe, and there should be no galaxies or stars after a certain distance. But as the Webb telescope looked into the early universe and beyond, finding more and more massive galaxies, it seemed we were looking at a different universe with different laws of physics. Well, it's not just about the massive and bright galaxies that existed beyond the dark ages. There are other things as well that don't follow our theories. Recent research has revealed a surprising twist in our understanding of the universe's early days. The fundamental laws of physics, which work so well for the nearby universe, might have been slightly different back then. A study published in the Journal of Cosmology and Astroparticle Physics suggests that gravity may have been about 1% weaker on very large scales in the early universe. This discovery came from analyzing data from the cosmic microwave background, which is the faint glow of radiation left over from the Big Bang. The CMB is crucial for understanding the universe's infancy, such as how the first galaxies formed and what happened right after the Big Bang. However, they found that their model didn't match the actual observations of the distant universe. When they adjusted Einstein's theory to account for a 1% weaker gravity, their model aligned more closely with the observed data. This small adjustment indicates that Einstein's theory might need some rethinking when it comes to the early universe. Another big problem in cosmology is that the latest observations from the James Webb Telescope show that the universe is not expanding uniformly everywhere. Astronomers have found that different methods of measurement give different values for the rate of expansion of our universe. Astronomers have already confirmed that all the methods are accurate. There is no error in measurement. This discrepancy in the value of the expansion rate suggests that the universe is expanding differently in different places, and the cosmological constant, known as dark energy, which is responsible for the expansion, is not actually a constant. It has different values at different places in the universe. All these discoveries, astronomers are now suggesting that the deeper we look into the early universe, our theories fail miserably. Several theories have been put forward in an attempt to explain this asymmetry, one of which is the idea that our universe collided with another when it ballooned out to an incredible size at a fantastic speed. In the multiverse hypothesis, our universe could have popped into existence near another universe. When it expanded, it ran into the neighboring universe, and this could be the reason why the laws of physics aren't uniform. Across the universe, in the southern portion of the universe is bound by a different set of physical laws than the northern side. This idea could explain the existence of strange and massive galaxies only a few million years after the Big Bang, as well as why the universe is different in different directions. Well, the discrepancy in our theories and observations in the early universe is now revealing many hidden mysteries of our universe. New pictures obtained from the James Webb Telescope are bringing new possible explanations about the existence of our universe. Either we are missing something big in our current understanding of the universe, or the early universe is beyond our understanding. Well, that's all for today. Hope you all liked this video, and don't forget to share your thoughts about this recent discoveries in the comments. Thanks.